Hello and welcome. Today we are going to look at an inverse function. More specifically, we are going to look at how you can find an inverse function for a quadratic equation. This question is an actual past paper question from IGCSE Additional Mathematics. Now, more details on where you can get the questions are down in the description below. First, we look at the question here. It says that the function f and g are defined for x is greater than 0 by these two expressions. Over here, you have to understand that the x greater than 0 here is referring to the domains of these two functions. So in part A, they say find and simplify an expression for f(g(x). So this is a very standard question for composite function. To find the composite function of f(g(x), it's basically the same thing as substituting the function g into the variable x under function f, which will give us this expression. So over here, you can see that all I have been doing is substituting the function gx into the x inside the function f. So now we can further simplify this, and we will get this expression, which in turn, we can finally simplify it and give us this as our final answer. So far, part A should be rather straightforward. Now we proceed to part B. In the first part, they say, given that f inverse exists, write down the range of f inverse. Once you understand inverse function, then this is going to be a rather simple question. The range of inverse function of f will just be greater than 0 in this case. Now, how do we know that? Suppose we look at a graphical representation of how a function works. So here we have two series or two sets of numbers, where the set of number on the left, I call it x, and the set of numbers on the right, I call it y. A function f with here will basically map every single number in the x to every single number in the y. For example, here my function fx is given as 2x. So therefore, every single number in x here, once they have been mapped under the function f, they will return back twice the value. So for example, when x equals to 1, after gone through function fx, it will become 2. Now, under this scenario, because our function f here will always map a number on the left side to another number on the right side, we say that the set of numbers on the left is known as the domain, whereas the set of numbers on the right side are known as the range. Now, the inverse function will basically try to do a reverse mapping compared to the function f. Now, in other words, if our function f will map all of the number on the left side to all the numbers on the right side, the inverse function of f will do a reverse mapping such that our inverse function f will be mapping the numbers from the right side to the left side. So you can see that the arrows, the direction of the mappings are in the opposite direction. So that is the nature of an inverse function. But we also remember that any function will always map any numbers in the domains to the range. So we can say the same thing for the inverse function, where the set of numbers on the right now becomes the domain of the f inverse, whereas the sets of numbers on the left side are now the range of the f inverse. By doing a simple comparison, we can easily see that the domain of the function f are the same thing as the range of the f inverse. Therefore, when it comes to this kind of question where they ask for the range of f inverse, the range of f inverse will essentially give us back the domain of the original function f. And the domain is already given in the first part of the question, where they mention that the domain of a function f is such that the x is greater than 0. Hence, our inverse function also has a range such that it is greater than 0. Now what about part 2? Show that f inverse x equals to this expression where p, q, and r are all integers. To understand how to do inverse function, we refer back to the diagram here. Now I have actually made a small mistake just now. Instead of f inverse x, it actually supposed to be f inverse y, because my inverse function is supposed to be mapping all the numbers on the right side to the left side. So the variable inside the bracket is supposed to be the y, since it's doing a reverse mapping. So in terms of theory, we can actually write it down such that y is equals to fx. Right, so our function f will map all the x into y. But the inverse function will actually do the opposite way, such that x equals to f inverse y. So now we can use these two properties to find the inverse function of any possible functions. In this case, for our function f, we are now going to make use of our very first expression here to get an equation involving both x and y, such that we will get y is equals to 2x squared minus 1 divided by 3x. Now, in order to find an inverse function, we need to remember that if y equals to fx, then f inverse of y will give us back x, which means that if we can get x to become our subject, or in other words, if we can get the expression for x, then we will have gotten the expression for the inverse function f. So we now proceed to try to simplify this equation by multiplying the 3x onto the left side so that we will get this expression, which we can again rearrange to give you a quadratic equation in this form. Now, in case if this is not obvious to some of you, let me rewrite it into this form, which clearly shows you that this is a quadratic function of x. Now we have a problem. How do we find the expression for a single x in this case? Now, because this particular quadratic equation equals to 0, it means that if you want to find the value or maybe any expression of x, you just need to solve for the roots of this quadratic equation. In general, to find the roots of a quadratic equations, you have three methods. You can do either the factorization, completing the square, or just using the quadratic formula. Now in this case, because one of our coefficient here involve y, so I think it's going to be a lot more straightforward if we just directly use the quadratic formula. Now please recall that the quadratic formula takes this form when your quadratic equations is in the form of ax squared plus bx plus c. So we directly apply this equation onto our expression here, so that we will get, so x equals to negative b. Our b in this case is negative 3y, so you must not forget the negative sign. So negative will give us positive, which is just 3y, plus minus square root of b squared, so negative 3y bracket squared, minus 4ac. So a here is our 2, and c, again, do not forget the negative sign here. So c is negative 1 in this case, divided by 2a, which is 2 times 2. Once you simplify the expression, you should get this. Now over here, we notice that there's a plus minus sign, but also remember that what's the range of x? It's already given that x is always greater than 0. So in order to make sure that the expression of x here will always give you a positive number, clearly we need to reject the negative answer, which means that we can replace the plus minus sign to just include the plus sign. So now by comparison, you can see that we are very close to our solution now. So recall that what is x? X is the inverse function of f with respect to y. So this x here is the inverse function of y. Hence, To get the inverse function of x, you simply replace all the y to become x, which will give us this expression where by comparison we can see that p equals to 3, q equals to 9, and finally r equals to 8. And that is it.